All right, so flipping over to section 4.2, number 32. 4.2, number 32 says, locate the critical points of the given function. Use the first derivative test to locate the local maximum minimums. And then C is identify the minimum and maximum values of the function. Identify the absolute minimum and maximum values of the function on a given interval when they exist. All right. So again, 4.2, number 32. So there's my function, negative x squared minus x plus 2 on negative 4, 4. So the first thing to do is look for critical points. So step A is going to be to find the derivative, because the critical points are always found where the derivative is equal to 0. So I'm going to take f prime of x. So negative x squared becomes negative 2x. Minus x becomes minus 1, and plus 2 just becomes 0. Okay. The next step that I would take is I would set that equal to, so negative 2x plus 1, I would set it equal to 0, and I would get 2x equals 1, or x equals 1/2. So I have a critical point at x equals 1/2. That's a good one to start with. And you know, I got to be careful here. Let's see here. Ooh, I screwed that one up a little bit here. Be careful here. I just noticed something. Eraser. Negative 2x minus 1. Okay. So I'll go back to my pen. Pointer options pen. Negative 2x minus 1, so this becomes a minus 1/2. So be careful on your signs there. It's always good to check that and just make sure as you follow through you're keeping your signs straight. So what I like to do now is determine if that's a local minimum or a local maximum. So in step B, what I'm going to do is I'm going to take points near that and determine what the slope is. So I'm going to take f prime of something smaller than that, f prime of negative 1. And f prime of negative 1 would be negative 1 times negative 2, which is positive 2 minus 1. That equals a positive 1. F prime of negative 1/2, negative 1/2 times 2, or times negative 2 is a positive 1. Minus a 1 is 0. Well, that makes sense. That's where our slope was equal to 0. It's kind of sad that I even checked that there. That was our critical point. And then f prime of, let's do a positive 1. So I picked something on either side of this guy. And so positive 1 would be negative 2 minus a 1. Minus 1 is negative 3. So what that means is, as you look at this, the slope is positive. Slope is positive. Slope is positive. Until it reaches negative 1/2. So when it reaches negative 1/2, at that point, the slope is 0. Okay? So positive, positive, positive. The slope is 0 at this point right here. And then the slope all of a sudden is negative 3 on this side. Negative, negative, negative. Well, you could check more points. But this is enough right here to tell you that this is obviously a local maximum and that we are concave down at that point in time. Okay, so local max at x equals negative 1/2. That's what we're really looking for right there. That's what we want to know. And then part C, I'm just going to look back at part C here again, here number 32, part C. Identify the absolute minimum and maximum values. So the only other thing is, like we talked about in the previous one, there we go, 4.2, number 32. Like we talked about the previous one, is your minimums, your maximums exist either at endpoints, like negative 4 and 4, or at critical points. All right. So let's test the critical points. Now the critical points, where we're going to test those, is we're going to take the function. So we're going to test all three of these. So we're going to say, okay, f of negative 4, which is my lower end, equals negative 4 squared is 16, negative 16, minus 4 is negative let's see here, negative 16. So yeah, negative 4 times negative 4 is positive 16. Negative 16, oh that's right, negative 16 minus a minus 4, which is plus 4. So negative 16 plus 4 is negative 12, plus 2 is negative 10. So at this point, we're at a negative 10. I'm going to go ahead and so this is an endpoint that I'm checking. This is going to be my critical point that I'm going to check, which was f of negative 1/2. All right, let's see here. Negative 1/2 squared is 1/4 minus 1/4 minus a minus 1/2, which would be plus 1/2. That's a positive 1/4. Plus 2 is 2 1/4, or we could also call that, I guess, 9/4. That's a positive number. And then the other endpoint is one that I would want to check. So I check the endpoints and the critical point. F of 4, negative 16. Yeah, so 4 squared is 16. Negative 16 minus 4. Negative 16 minus 4 is negative 20, plus 2 is negative 18. Good. We got a number there that we like. All right. So it's worth looking at this and saying, oh, well, this is a little bit more interesting now. This, x equals negative 1/2, actually represents my absolute maximum. And this, x equals 4, actually represents my absolute minimum. So even though on this previous part we determined that, yes, this was a local max, what we've also determined is x equals negative 1/2 is actually my absolute max, and x equals 4 is my absolute minimum. So it takes a few more tests to know exactly what those numbers mean.